All right, today we are going to utilize coordinate geometry. You've found slopes and lines before, but we're going to continue to do that. We're going to expand with the slope by identifying different types of lines. After we identify the lines, we can write equations. So this is what we're going to be doing today. We have some I can statements. You need to be sure and write these down, because by the end of this lesson, these are the skills that you're going to utilize. You know, you will, it says I will because you're writing it for you, I will use the point slope form of a line. Okay, this point slope form of a line I love it, because regardless if you can utilize the point slope form of a line, you can write the equation of any line. Each time, every time, all the time, regardless of the form they ask you to put it in. Okay, so point slope form is our first go-to when we're writing the equation of a line. Okay, I will use point slope form of a line. I will use the slope intercept form of the line. I will use the standard form of a line. You will also, I will identify slopes of parallel lines. I will identify slopes of perpendicular lines. I will define parallel, perpendicular, and skew lines. I will write linear equations. So we've got a lot of I wills just in this one lesson. Okay, now we're going to define these. We've defined a lot of them before, but we're going to do it again. A line consists of at least 2 points. A line cannot exist unless we have at least 2 points. At least. That means I can have 2, or I could have more, but I have to have at the very minimum 2 points for a line to exist. A line has no beginning, no end. It goes on infinitely in both directions and cannot be measured. Okay? Parallel lines. Parallel lines are in the same plane. Same planes means they're collinear, just like if 2 points are, same plane is coplanar, just like collinear points lie on the same line. Coplanar, same plane, collinear, same line. Okay, parallel lines are coplanar, or are in the same plane. They have the same slope. Same and equal and congruent are all interchangeable. We have to know that all of those go together. And parallel lines never ever intersect. They'll never ever meet. It's kind of sad. They're so alike, yet they'll never ever meet. So, stupid joke, but that's okay. Perpendicular lines. Perpendicular lines are also coplanar. They lie in the same plane. Now, but perpendicular lines have opposite reciprocal slopes, okay? So opposite, that means one's positive, one's negative, and reciprocal. You have one and then the other one is flipped. So they have opposite reciprocal slopes. You can also think about perpendicular lines, their slopes, their product, that means the answer to a multiplication problem. The product of their slopes, each time, every time, all the time, will equal a -1, okay? Perpendicular lines also intersect to form a 90-degree angle, okay? Now, I did throw skew lines in here. We don't write equations of skew lines, but we've talked about those, and I want to talk about skew lines. Skew lines are not in the same plane, so they do differ from the parallel lines at not being in the same plane, so they are not coplanar. But yet skew lines never intersect, okay? So just because you have 2 lines, you're told these 2 lines don't intersect. They may or may not be parallel. It depends on, are they in the same plane or aren't they in the same plane? If they are in the same plane, we can say they're parallel. If they are not in the same plane, we have to say that they're skew, okay? So we have to keep that in mind. All right, types of equations, of linear equations. We have point slope form, okay? This is the formula. I'm not gonna regurgitate, you can read that. Here's how I say it. Y minus your y coordinate equals your slope times x minus your x coordinate, okay? So for point slope form, all you need a point on the line, any point on the line and the slope. If you have the slope at any point on the line, you can write the equation of the line, okay? Now, I'm gonna tell you, I'm gonna start you out each time, every time, all the time in point slope form. Now, from point slope form, we can manipulate it into slope intercept form or standard form. We're most familiar with slope intercept form. y equals slope times x plus or minus your y-intercept. This is here. But here's the deal. On a y-intercept, technically an intercept is a set of points. So your intercept isn't b, okay? Your y-intercept is not just b, this entire thing, okay? It is a set of coordinates 0, b, okay? Each time, every time, all the time. So when I ask you for the y-intercept, you're never going to tell me, oh, it's 7, oh, it's 5, oh, it's -3. You're never, ever going to tell me that. You are going to give me a set of points. Every single time, my x-coordinate will be 0 if it's a y-intercept. It will be 0 if it's a y-intercept. But again, an intercept is a coordinate point on the y-axis. So we need to remember that, okay? Now, we utilize standard form, okay? We will use this about as much, if not more, than we use the slope-intercept form. Just because we're used to using this, we'll probably focus on this just a little bit more, okay? Now, standard form. A is the coefficient of x, B is the coefficient of y, equals C is your constant. So, here's how I talk about standard form. You have x and y on the same side. You have all integers. That means you have no fractions. So this is a nice pretty number, this is a nice pretty number, and this is a nice pretty number. No fractions are allowed in standard form. Then there's one more condition. Our leading coefficient, our a, cannot be negative. Okay? So standard form. Okay? ax plus by equals c. X and y are on the same side, and c, constant, is all by itself. So you have to know this form. You have to remember that our leading coefficient, our a value, cannot be 0. You have to remember that we have no fractions. And we'll get to that. I'll show you. If we did get a fraction, we're gonna get rid of it easy peasy, okay? All right, so here we go. We're gonna start out just recognizing slope when it's in slope-intercept form or when it's standard form. Now, a dream worksheet would be worth 100 points, and yet, even if it was 100 problems, and all of those were identifying the slopes when it's in slope-intercept form. Easy peasy, okay? So I'll just throw one up there. So I have a y equals 1/3 x minus 7. Well, the slope, each time, every time, all the time, in slope-intercept form is the coefficient, the number in front of x. That's why I do not say y equals mx plus v. I say y equals your slope times x plus your y-intercept, okay? So my slope on this line, slope, is 1/3. It is not 1/3 x, it is 1/3, okay? Let's do another one. Y equals -3x plus 5. Again, the slope is the coefficient of number in front of x. The coefficient number in front of our x variable is a -3. So in this instance, my slope is a -3. So identifying them when they're in slope-intercept form is fantastic. It's easy peasy. We'd love to answer those all day long. When we get to standard form, you can absolutely put it in slope-intercept form. You can. I am all about let's work smarter, let's not work harder. So I would have to do a whole lot of manipulation to get the slope, okay? Well, what if I told you that, well, I tell you what, I'm not gonna tell you anything. I'm gonna erase this. I'm gonna make up a line. I'm gonna put it in standard form, no fractions. I like small numbers, let's go. 2x minus y equals 3. Okay, so this is my line. I'm gonna pretend I have no other choice But to put it in slope-intercept form, like I said, that's going to be a lot of work. I have to isolate y. I have to get y completely and totally by itself. So we're moving everything away from y. So 2x is over here. I need to move it to the other side. That's a positive 2x. I need to use the additive inverse, a negative 2x. Okay, what I do to one side, I do to the other side, minus 2x. My handy-dandy line I'm going to add straight down. 2x minus 2x is 0. Additive inverses are supposed to equal 0, to add to 0. Bring down, don't forget your sign, negative y equals negative 2x and a positive 3. Because slope-intercept form, x is out front. Okay. Well, y is not completely and totally by itself. It is multiplied by a negative 1. That's why you have a negative y. So I have to divide everything by a negative 1. Key word here being everything. So this is divided by negative 1, meaning this is divided by negative 1, meaning this is divided by negative 1. Okay, negative over negative make for a positive, y equals negative 2 over negative 1 is a positive 2. Then I have my x, and then a positive 3 over negative 1 is a negative 3. I now have my standard form of a line in slope-intercept form, okay? So therefore, I can identify the slope. The slope is the coefficient of x, number in front of x, which is 2. So my slope is 2. Okay. I told you, I'm all about let's work smarter, not harder. That took us a little bit, and we need to be efficient with our time. Nobody ever has enough time to get done everything they want to get done. So we need to utilize time-saving factors. So what if I told you when your line is in standard form, the slope each time, every time, all the time would equal, okay? And I'm actually going to write the word slope. The slope will equal, when it's in standard form, listen to the words coming out of my mouth, the opposite of the value of A over exactly what the value of B is. Okay. I just found the slope of this line by putting it in slope-intercept form. All right, so I'm going to test that. My A value right here is 2. Okay, I'm going to write this in blue. My A value is 2. So if my slope is the opposite of A is 2, I want the opposite of 2, so I would get a negative 2 over exactly what B is. Keep the sign with the number. B is the coefficient of y, and it's a negative y, so it's an understood negative 1. So I have B is a negative 1, exactly what B is. Keep the sign with the number. A negative 2 over a negative 1, negative over a negative make for a positive, and I have a positive 2. Oh man, I was right. I would much rather remember when it is in standard form, my slope is the opposite of A over B. It's a lot more efficient, okay? So be sure you put that in your journals. You star it, you highlight it, whatever. You have to know this in order to be efficient with your time, okay? We don't want to do more work than we absolutely have to. Okay, so we're going to jump right in. We're going to determine if lines are parallel, perpendicular, or neither. Well, first of all, I would like to remind you, parallel lines have the same slope. So if this line has a slope of 1/2, then a line parallel to this line would also have the slope to 1/2. Each time, every time, all the time. Okay? And actually, let's just throw a quick blank sheet up there. That's not what I wanted. Let's throw a quick, yeah, that is what I wanted. Nope, I want it in front of that. Okay, so we're gonna do just a quick exercise, okay? Like I said, I wanna remind you, parallel lines have the same slope, have congruent slopes. Perpendicular have opposite reciprocal. So we're going to be given a number, and then we're going to go parallel slope, because that's the symbol for parallel. This is the symbol for perpendicular, and we have perpendicular slope. Okay, so we're going to talk about that. Okay, this is our given slope. Okay, this is our given slope. This would be a line parallel slope, and this would be a line perpendicular slope. So let's say, I don't know, make it easy. Given the slope 3, and then we'll give the slope of a negative 2/3, and then we're going to be given the slope, I don't know, 1/7. I think that's good enough. I think that will get us what we need. Okay, so I want to say, hey, Kate, if I have a line with the slope of 3, the parallel line to this one, to this 3, to this line that has a slope of 3, well, the parallel slope would also have to be equal or congruent, so it's the same thing. So the parallel slope has to match the slope of the line that I'm given. Okay, so, okay, that's really easy, okay? So the parallel slope here, that's a negative 2/3, so okay, that's gotta be a negative 2/3. Great. The given slope is 1/7, so the parallel slope has to be 1/7. Easy peasy. If I had this, man, we would kick it out. We wouldn't make an error at all, okay? Unless we started making up numbers like Mrs. Fields does sometimes. Now, if I want the perpendicular slope, okay, my given slope is 3. Perpendicular is opposite. If that's positive, my perpendicular slope has to be negative. All right, negative. And that's a positive 3. A positive 3 is the same thing as 3/1. So a perpendicular slope is opposite reciprocal. Flip it. A negative 1/3. You flip it. So the given slope, the given line has a slope of 3, so the line perpendicular to that has to be a negative 1/3. Okay? So, same song and dance. If this is negative, my perpendicular slope has to be positive. This is already a fraction. Just flip it. Okay? 2/3 becomes 3/2. Opposite reciprocal. Reciprocal means I flip it. Okay? This one, positive 1/7. So the perpendicular slope has to be negative. 1/7, flip it, is 7/1. We don't need that 1. So it'd be a negative 7. Okay? So this gives us an idea of what we're about to check. Okay? Now this, we're going to determine if they're parallel. If their slopes are the same, they'll be parallel. If their slopes are opposite reciprocals, one's positive, one's negative, and then the reciprocal of each other, then they're perpendicular. But if they're not the same and they're not opposite reciprocals, then it's neither, okay? So what we have to do, and I made these easy, we're going to identify the slopes of each of the lines. So these two lines. Are these perpendicular, parallel, or neither? Well, the slope of this line, first line, we're going to go line 1, line 2. I'm going to put slope of line 1, line 2. Slope of line 1 in slope-intercept form, y equals slope times x. Slope of line 1 equals 2. Well, the slope of line 2 is a negative 2. Well, they're not the same, so they're not parallel. They are opposites, but they're not opposite reciprocals. The opposite reciprocal of 2 would be a negative reciprocal 1/2. So these two lines are neither parallel or perpendicular. They are neither parallel or perpendicular. Okay, we're gonna look at this one. Okay, same song and dance. I'm gonna do this one and this 2. So here's the slope, line 1, line 2, okay? Okay, the slope of line 1, again, these are in slope-intercept form. Y equals slope, coefficient of x, times x minus 3. Slope of line 1 is 1/4. Okay, slope of line 2 is a negative 4. Coefficient of x, number in front of x. One's positive, one negative. The reciprocal of 1/4 is 4/1. So these do have opposite reciprocal slopes. So these are perpendicular lines. So that means they will intersect to form a right angle. Each time, every time, all the time. Okay? So that's why we have to know about the slopes of parallel and perpendicular lines. Okay? Let's see what else they gave us. Ooh, they didn't give us, this is they were kind of nasty on this. Okay, one of these is in standard form. One of these is in slope-intercept form. So I'm gonna be a little lazy. This one's slope-intercept form, and the slope is the coefficient of x. Yes? Okay. So the slope of this line is a negative 1/3. So I have a negative 1/3 slope. I need the other slope. So I can just say this is slope 1. Okay. So now I need the other slope. Slope 2. Okay. In standard form. Well, standard form, the slope, remember, slope would be the opposite of the value of A over exactly what the value of B is. Well, A is the coefficient of x. A is 3. The opposite of 3 is a negative 3 over exactly what B is. Okay, B is the coefficient of y. That's a positive 1. Keep the sign with the number. A negative 3/1, which is a negative 3. Ooh, that's a negative. That's a negative. These would not be parallel or perpendicular. In order to be parallel, they have to be the same. These are not the same. So this set of lines would be neither. They are neither parallel nor perpendicular. Okay? Man, they did it to us over here as well. I have one in standard form, and I have one in slope-intercept form. I'm going to do the same song and dance. All right? I'm going to go with the easy one first, the coefficient of x, okay? So the slope of line 1, okay, is a negative 2/3. In order to be parallel, my other slope has to be a negative 2/3. In order to be perpendicular, it has to be the opposite reciprocal. So we've got to find the slope of this one because it's not in slope-intercept form. And again, I want to remind you, in standard form, the slope, each time, every time, all the time, will equal the opposite of the value of A over exactly the value of B. Well, in this instance, A is 2, B is a positive 3. Okay, I don't care about that 6, X and Y. Oh, that's 3X and 3X. Oh, look at that. That is not a Y. 2X plus 3X, we need to go ahead and simplify that. That's 5X minus 6 equals 0. Okay? Add 6 to both sides. So 5x equals 6. I've gotten standard form. Oh, gee. A is going to be 5. B is going to be 0. Okay? So, because y isn't there at all. So I almost screwed up. I didn't pay attention to how it was written. 2x plus 3x. Okay? That's 5x. All right. Well, if A is 5, the slope of the line 2. If A is 5, the opposite of A is a negative 5 over exactly what B is. Well, y is not there. What number do I multiply to y to make it go away? 0. Can we divide by 0? Ever, not ever. So it's not possible. So this slope is undefined. Each time, every time, all the time, an undefined slope gives us a vertical line. That's a vertical line. That slope is 2/3, a negative 2/3, I'm sorry. Regardless, they're not parallel nor perpendicular. Wow. So they did throw a fast one on us. But we did determine, are they parallel, perpendicular, or neither? Okay? So we're going to do some more. Okay? I'll have to erase and stuff, but that's okay. All of these appear to be in standard form. Okay? So again, I want to remind you, in standard form, our slope in standard form is the opposite of the value of A over exactly what the value of B is. So I'm going to find the slopes Actually, let's be sure you have that down handy and near you. I'm going to write it a little small. I'll do it right up here. Slope is the opposite of A over exactly what B is. Okay, so A is 1 here. So the opposite of 1 would be a -1 over exactly what B is. B is a +2. Nothing to simplify, so the slope of this line right here is a -1/2. So now let's find the slope of this line. A is 1. The opposite of 1 is a -1 over exactly what B is. B is a negative, oops, I'm putting the flies in here. So I got a -1, which is A, over exactly what B is, which is a -3. A negative over a negative make for a positive, so I get a +1/3. Regardless, these two are not the same. That means they are not parallel, and these two are not opposite reciprocals. Now, one's positive, one's negative, but they are not reciprocals of each other. So these are neither parallel or perpendicular. And to show your supporting work, to when you give your answer as neither, they're neither parallel or perpendicular, your supporting work would literally show the slopes are not equal. All right. This one over here, same song and dance. A, I'm going to write it over here. Let's do it in red. A is 4. The opposite of 4 is a -4 over exactly what B is. B is a -1. -4 over a -1, oh, I'm running out of room, darn it, is a +4. Negative over negative make for a positive. So this line has a slope of 4. So if this line is parallel, this line will have a slope of 4. If this line is perpendicular, opposite would be negative, reciprocal would be 1/4, so it would be -1/4. So let's find out what this is. The opposite of X is 1, or A is 1, so the opposite of A is a -1 over B exactly 4. So we do have a -1/4. So we have 4 and a -1/4, and so these are perpendicular lines. I can't spell. So these are perpendicular lines. Okay, we're going to work on our third one, determining if these two lines are parallel or perpendicular. If they're parallel, their slopes are the same, equal. If they're perpendicular, their slopes are opposite reciprocals. Okay, that means the product of the slopes would equal a -1. Now, these are both in standard form. The slope can be found in standard form, quick, simply, and easily, if we remember that the slope is the opposite of the value of A, which is the coefficient of X, over exactly the value of B, which is the coefficient of Y. Remember, we always keep our signs with our numbers. So on this one right here, A is 6. The opposite of a +6 is a -6 over B. B is your coefficient of Y, -2, -2. Negative over negative make for a positive. 6 divided by 2 is 3. So the slope of this line right here is 3. Now we have to find the slope of this line. A is 3, so the opposite of A is a -3 over exactly what B is. B is a -1. -3 over -1 is a +3. These slopes are equal. They are the same. They are congruent. That means these two lines are parallel lines. So these two lines are parallel lines. All right. So just a reminder, okay, in determining slope, there's a couple of ways, okay? If it's graphed, you can absolutely count. Change in Y over change in X. Vertical change over horizontal change. You can count from one point to the next. How far up did I go? How far over did I go? Okay, but what if the lines aren't graphed? Well, if the lines aren't graphed, we can still go to our delta Y over delta X. Delta meaning change. Change means difference. Difference means subtract. So I would subtract my Y's over subtracting my X's. Okay? And on these, the next slide, we have several problems. We're only going to do a couple. We're going to find the slope of the line passing through one. I'm just going to do, I don't know which ones. I'm going to do A, B, and maybe D. Okay? And it doesn't matter. which set of coordinates I use first. If you use this y first, then you use this x first. That's it. You just have to be consistent. And again, we're going to do A, I'm going to go ahead and do B, and then I'm going to do D, okay? So those are the three that we're going to do right now. Now, again, a reminder, slope is vertical change over horizontal change. Delta y over delta x. Delta means change, change means difference, difference means subtract. Subtract our y's over our x's, subtract it. So I'm going to use this set of points first just because I want to. Again, it doesn't matter as long as I'm consistent. So I'm going to use this 0, and because I use this 0, I'm going to use that -2 first, okay? So I'm going to have 0 minus 1 over -2 minus 3. Change in y over change in x. 0 minus 1 is a -1. A -2 minus 3 is a -5. A negative over a negative makes for a positive 1/5. So just a quick recap on how we find the slope of a line, okay? I'm going to go ahead and do B. Again, change in y, doesn't matter which one we use first, does not matter. Okay, I tend to just, this was the one that's given to me first. I use this 2 first, this 2 minus this 2 over this -1 minus 2. 2 minus 2 is 0 over 1 minus 2, which is a -3. Okay, 0 divided by any number is 0. I can divide 0 by any number that I want. It's always going to be 0. Okay, I just cannot divide by 0. Okay, we're going to do D. We're not going to do them all. Again, I'm going to use this one first. It does not matter if you want to use that one first. Do it. As long as our math is accurate, we will get the same answer. So I'm going to have 4 minus 1, 4 minus 1 over, oh, here we go, 3 minus 3. 4 minus 1 is 3. 3 minus 3 is 0. I just told you we can't divide by 0. This is not possible, okay? When you get something like this slope is undefined, okay? This slope is undefined, okay? And actually, let's think about it. This is a vertical line, but let's say we don't know that, okay? I've got my graph right here, okay? I've got this, a line contains these 2 points, okay? So I got 1, 2, 3, 1, 2, 3, 4. I've got 3, 4 right there, and then I've got 3, 1. That is a vertical line. The slope of each vertical line, every vertical line, all the time is undefined. You have an undefined slope on every single vertical line that you have, okay? So, okay, just to bring it to your attention, this 0 slope, and actually, let's look at that one real quick. A 0 slope is going to be a horizontal line, okay? Let's go. What is this? 2. All right, so this one's -1, +2, -1, +2. And this is a +2, 1, 2, +2. So this line is a horizontal line. Each time, every time, all the time, a horizontal line will have the slope of 0 every single time. And just like each time, every time, all the time, a vertical line, I don't care where it's at, is always going to have an undefined slope. Horizontal line will always have a 0 slope. A vertical line will always have an undefined slope. Okay. We're going to find the slope-intercept form of the equation of the line. So we have to write the equation of a line. They told us that has a slope. They gave us a slope and passes through this point. Okay, so let's think about this. They gave me a slope and they gave me a point. And if you recall, I told you when we write equations of lines, we're 99% of the time, we're going to start out in point slope form. Okay? So point slope form. I probably should have posted that. So point slope, y minus my y coordinate equals my slope times x minus my x coordinate. I'm just going to take this information and put it in that equation. That's all I'm going to do. y minus the y coordinate, that's the y coordinate, minus a negative 2 is actually plus 2, equals the slope. The slope they gave me was 3, times x minus the x coordinate, which is 1. That is point slope form. All I have to do now is manipulate the equation to whatever form they asked me to put it in. They asked me to put it in slope intercept form. That means y is isolated. Okay, so here I go. I'm going to rewrite this. Y plus 2 equals 3 times x minus 1. I'm going to start isolating the y. In order to do that, I need to distribute this 3 to everything in the parentheses. Y plus 2 equals 3 times x, which is 3x. 3 times a negative 1 is a negative 3. I'm not done because y is not completely and totally by itself. So next step, I'm going to subtract 2 from both sides. Handy dandy line. Okay? Y equals 3x minus 5. Now, it's very easy to see, hey, are we probably right? You know, I have a slope of 3. That's what I'm supposed to have. I put it in slope intercept form, okay? But again, I want to be specific. I want you to utilize the point slope form each time, every time, all the time, okay? So I know there's other ways to do it. We are going to specifically work with point slope form. Let's look at what we've got next. Okay. Write the slope intercept form of the equation of the line described. Okay, they've changed it up a little bit. So it has to contain this point, the line does, and it has to be parallel to this line. Okay, well, they didn't give me the slope, but what they did give me is that it was parallel to this one. If we make the connection, parallel lines have the same slope. I have the slope, I have a point, I've got point slope form. So over here, this is already in slope intercept form. Y equals slope times x plus or minus your y-intercept. The slope here is an understood 1. So the slope of this line is 1, okay? So I'm just gonna lightly, let's not do it in black. I'm gonna lightly put, so there, m is 1, my slope is 1. Okay, so I have my slope and I have this point. I don't care anything else about that particular equation. I just needed that equation to get the slope. So I'm going to utilize point slope form, okay? Point slope form. Y minus my y coordinate minus a negative 1 is plus 1 equals my slope, which is 1, times x minus a negative 2 is plus 2. And they told me to put it in slope intercept form. Isolate y. Same song and dance. Y plus 1 equals 1 times x is x. 1 times a positive 2 is a positive 2. Isolate y. Subtract 1 from both sides. Y equals x plus 1. So this line is parallel to that line. And let's check, is that slope 1? Yes. Is that slope 1? Yes. So these two lines will be parallel. Okay. Same song and dance. Write the slope intercept form of the equation of the line described. Okay. Again, it's parallel. They gave us this so we know the slope that we're working with. And this is my point. So my slope here is not an understood 1. It is the coefficient of x. Okay. So it's a negative 5/4, parallel. Same slope. Okay, so here I'm going to utilize my point slope form. Y minus my y coordinate, which is 5, equals slope. Not real crazy about a fraction, but I can still do it. Slope times x minus a negative 2 is plus 2. Okay, now, most of you are going to see that fraction and go, oh my Lord, I do not want to work with that fraction. So I can work with fractions. I don't mind working with fractions. But you know what? Let's just not, okay? This term is multiplied with this term. So what I'm going to do is, this is the same thing as over 4. So negative 5 times this over 4, same thing. So divided by 4. So what I'm going to do is just get rid of that 4. and and this fraction bar is a division bar. So to get rid of it, I need to, I don't like that, I need to multiply both sides by 4. And since this is multiplied to this, I'm only concerned with these two. So a negative 5/4 times 4, okay? But what I do to one side, I have to do the other side, okay? So on the left, I get 4 times y, 4y. 4 times a negative 5 is minus 20. Okay. On the right side, these 4's cancel. They will cancel. So, and here I'll show you. I got a negative 5/4 times 4, and actually times x plus 2, because I can multiply in any order that I want. Okay? So I'm just showing you that's what this whole side is. These 4's cancel, making our lives way easier. So on the right-hand side, I literally have negative 5 times x plus 2. Hey, this looks way better than having to work with the negative 5/4. Now, like I said, I can. That's not a big deal to me, but people seem to be intimidated by fractions. Okay? So I'm just showing you how we don't have to work with them. Same song and dance. I'm going to distribute that negative 5. I'm going to solve for y because they asked me to put it in slope-intercept form. Okay? So on the left, I still have 4y minus 20. On the right, negative 5 times x is negative 5x. Negative 5 times a positive 2 is a negative 10. I need to isolate y. To do that, I need to add 20 to both sides. I'm going to end up working over here. I don't have enough room to work vertically. I get 4y equals, make sure those are additive inverses and cancel, equal negative 5x, negative 10 and a positive 20 is a positive 10. So I'm going to rewrite this right over here. Let me erase this. That was just showing you my work over here. I've got 4y equals a negative 5x plus 10. Y is not isolated. I have to divide both sides by 4. When I divide both sides by 4, I'm literally dividing everything by 4. So that means this is divided by 4, this is divided by 4, and this is divided by 4. So this becomes y equals, that's negative 5/4 times x. Be sure your x is clearly not in the denominator. Mine's clearly not in the denominator. Plus 10 over 4. Okay, what happened here? 10 over 4. I'm not sure what happened. Let's see if I can make, there we go. 10 over 4. 4 doesn't go into 10 nice and pretty. Wow. Let's see what I can do here. It doesn't go in there. There we go. 10 is not divisible by 4. Okay, we would have a remainder, but we can reduce, and I want you guys to work with improper fractions, okay? So 2 goes into 10, wow, this just really didn't like me. 2 goes into 10 5 times, and 2 goes into 4 twice. So I end up with 5 over 2, okay? Let's see if I can get over there and maybe it'll let me reduce that. Not sure, but we're gonna try it, okay? So 2 goes into 10 5 times, 2 goes into 4 twice, so I end up with 5 halves. So I have written the equation of the line that is parallel to this one, and it does contain this point. I've got fractions, but I don't care. My slope is a negative 5/4. My slope is a negative 5/4. And if you want to make sure that you're right, take this point, negative 2 and 5, plug in 5 here, negative 2 there, and see if you don't get a true statement, okay? You can always check your work that way. Oh, I need to be here maybe? Oh, no, I'm good. Okay, this one, same song and dance, except, and we have to be careful, don't make the assumption it's the same as the other ones. I'm still, oh, look at that. Let me make sure that's not the first one. No, it's not. I'm writing it in standard form this time. Standard form, x and y are on the same side. The constant is on a side all by itself, and there's no fractions, and then my x, the leading coefficient, my a value can't be negative. So again, I'm gonna put up here, standard form ax plus by equals c. A is the coefficient of x, b is the coefficient of y, c is your constant number all by itself. There are no fractions, and a is not negative, okay? So we're writing the standard form, this form, oh, and it's perpendicular to this one. So perpendicular lines do not have the same slope. They have opposite reciprocals. This right here is a positive 1/3. So I have a negative, okay? 1/3, flip it, reciprocal is 3/1, which is simplified to a -3. So a -3 is my perpendicular slope. And remember, perpendicular lines intersect to form right angles. All right, so now that I have my slope and I have my point, I put it into point slope form. Y minus my y coordinate equals my slope times x minus a -1 is +1. This is point slope form. I need it in standard form. All right, I'm still going to distribute y. Oh, I'm sorry, making up my own signs here. Y minus 2 equals a -3 times x is a -3x. -3 and a positive times a +1 is a -3. Okay, I'm on a roll. X and y have to be on the same side. So I'm going to add 3x to both sides. So now I get 3x because it's ax plus by equals c. 3x, that's a positive y minus 2, because I haven't done anything with that 2. Add of inverses cancel, equal a -3. Well, x and y are on the same side. That constant needs to go the other way. Okay, so I better get rid of that -2. So I'm going to add 2 to both sides. And then I get 3x plus y equals, because these are out of inverses, -3 positive 2 is a -1. So the equation of this, or the standard form of the equation of the line that's perpendicular to this and contains that point is 3x plus y equals a -1. And in a perfect world, I could have shown you everything vertically, because we are going to work vertically with all of our steps easily read, okay? Oh, we're doing standard form again. Okay, well, my slope here is 4/5, okay? That's a positive. Perpendicular, if that's a positive, my perpendicular slope is gonna be negative, and it's a reciprocal. Flip it, 5/4. So that's the slope I'm gonna use. I have the slope and the point slope form. So here I go. Y minus a -3 is +3 equals my slope, -5/4, times x minus my x coordinate. Now again, I can work with fractions, but I'm going to tell you right now, it would be way easier if we didn't. We got to get in standard form anyway. We don't want any fractions to start with. So we're going to do the same thing that we did earlier with the parallel line when I had a fraction. I'm going to get rid of this 4. This is the same thing, and I'm going to write it over here. This is the same thing as a -5 times x minus 4 over 4. That's the same thing as that. It's just written differently. This whole thing is over 4, okay? So I want to get rid of the 4, so I'm going to multiply this side by 4. And what I do to one side, I do to the other side. Multiply this side by 4, okay? In doing that, I get 4y plus 12 equals a -5. No, that's not true, okay? These 4's will cancel, a -5 times x minus 4. I made my life so much simpler. Didn't have an anxiety attack, didn't have to worry about fractions. All I have to do, again, I'm standard form, x and y are on the same side. My leading coefficient, my a value can be negative, and I have no fractions. I can do that. I'm going to distribute. I've got 4y plus 12 equals -5 times x is a -5x. -5 times a -4 is a +20. X and y have to be on the same side. I'm going to add 5x to both sides. I get 5x plus 4y plus 12 equals 20. And in a perfect world, like I said, I can scroll down. Okay, I'm going to recopy this up here. I've got 5x plus 4y plus 12 equals 20. I gotta get my constant to the other side. So I'm gonna subtract 12 from both sides. I've got 5x plus 4y equals 20 minus 12 is 8. X and y are on the same side, leading coefficient is not negative, and I have no fractions. Okay, let's see what we have next. And we are done.